Hey guys, today I wanted to talk about this little guy right here. Some technicians will call this a refrigerant control valve. This controls the refrigerant output at the compressor and at the AC compressor in a lot of automotive applications. So my car is a Volkswagen Jetta 2010 with a variable displacement AC compressor, and what it was doing was it was intermittently working. It would start out hot, it would blow hot air, and then after a few minutes it would kick in and then blow cold air. And then it got so bad that at some point it just stopped blowing cold air altogether. And I just wanted to tell you how to go about diagnosing one of these, what steps you're going to want to go through, and how to kind of nail it first try. There's various problems that could actually arise in AC systems, and it's important to know how to approach each one in a very systematic way to get the right answer. Anyway, let's dive in. So one of the important points I want to make about these is, if you look at this little filter screen here, you can see that there are some shiny metallic pieces in there. Let me see if I can zoom in a little bit. Some of this is potentially just debris, and some of it is like compressor seal debris, and some of it looks like maybe compressor material. My car has over 246,000 miles. It's reasonable to assume that if I pull this valve out and I see a lot of this silvery shrapnel, that the aluminum is kind of wearing on the compressor. And so that's one thing you want to keep in mind. You could potentially replace one of these guys, and literally within a few days or a week, if the compressor is coming apart internally, you might end up with the same exact issue that you started with, or even worse. So I just wanted to bring that up. So without further ado, let's go diagnose. All right, so we're in the car. I just want to go ahead and tell you guys how this typically manifests, or at least the way I've seen it in my professional career. And usually the customer would come in and complain that for the first minute to 2 minutes or so, the AC would not turn on right away. It would just kind of delay, and then it would eventually kick in. And typically what would happen is it would manifest, this issue would manifest on a day that's pretty hot outside. So it would be sitting in the sun or sitting in the heat for a while, and then they get in the car and it takes a few minutes for it to actually kick in and cool down. And some of you might be thinking, well, come on, Mike, you're obviously in a tropical climate. It's a hot day. Of course it's going to take the AC a few minutes to cool down. Well, I'm here to tell you that these Volkswagen AC systems are pretty efficient, and if it takes more than maybe a minute or two to cool the interior down, something's wrong. And so, in fact, every single time I got a customer complaint about this particular issue happening, it was the very beginning stages of this valve in the failure condition. And so what I'd like to show you guys today is how to actually hook up all of the test equipment and catch this thing in the act, diagnose it right the first time, and not waste too much of your time. There are 3 steps that we need to do next. And the first one is we need to kind of get that undercover taken off so we can access the electrical connector underneath that plugs into this control valve. If I just go straight to the connector and I sample the voltage at the valve, that tells me a lot of information. But simultaneously, what we're going to do is we're going to measure the pressures. And notice we're sitting outside in the sun on a hot day. This is what I encourage you to do, especially if you have one of these that's intermittently just not working very first thing on startup. So you want to have all this set before you even start, so you can kind of take a multi-dimensional approach. And that's what I'm going to show you here today. We're going to basically tap into that AC compressor electrically. We're going to hook up our scan tool, and we're going to make sure that the ECM is telling the valve to turn on. And simultaneously, we're going to look at the refrigerant pressures and make sure that those are also not doing anything while the computer is commanding this compressor on, and sampling the voltage and making sure the circuit's intact all the way to the compressor valve itself. And with that multi-dimensional approach, we can basically know everything we need to know in one shot. All right, here we go. All right, guys, so if you don't have one of these nifty kits to do electrical testing, measurement, and all of that, I certainly recommend you get them. They've got all these neat leads that you can buy, and you know, like you can plug these into the pins without damaging the connectors, and you can check pins without having to, you know, stick the lead down there in some cases. So this is a pretty handy kit here. It comes with some leads, some traditional test ends, some 5 ohm variable resistors, and you got some Y connectors here. Let's see, yeah, these guys are super handy here for back probing, and this is what we'll use today for testing the voltage at the refrigerant control valve. So these guys are pretty handy. You just plug them into the leads here, plug them into the meter, and then back probe the connector, and then you don't have to worry about shorting the connector together. All right, so we're gonna go ahead and unplug our control valve connector here, which is right here. So there's the right front tire AC compressor, and our connector is right there. That's what we're going for. We're gonna unplug this, and in order to do that, you just kind of, I like to push the connector forward just a little bit, and then if you can get your thumb on the tab, you hear that click, then you can walk it back just a little bit like that, and there you go. Then you got your connector off. We're gonna go ahead and back probe so that we can measure a voltage drop across it. Because this, I believe, is a pulse width modulated, either that or a duty cycle operated valve, you're not going to see supply voltage. But if you probe into the back here, you have a pretty good idea using our special leads here what we're looking at. So I'm going to go ahead and back probe our connector here. All right, yeah, it would have been really tough to hold the camera while doing all that, but as you can see, I've got the probe ends plugged in there, and it feels like I'm touching the connector on the inside. You'll notice I don't like to stab the wire. I like to go in past the insulation boot on the end of the connector piece. There's a reason for that. I absolutely cannot stand puncturing the insulation and then not redoing it because of moisture contamination, corrosion, and things like that. I don't like causing problems in electrical systems that don't need to be there. So always, always, always back probe. Stabbing wires, another point about that is sometimes the way that they do the wires nowadays is so fine. Like there's so few copper strands in there that one stab will break the wire. So you might actually test good on your electrical test, but once you've broken that wire, you've introduced a new problem. All right, so it looks like I've got my meter set up. I've checked the connections, making sure that everything is good to go. Let's move on to hooking up our AC gauges. All right, so when you're hooking up these gauges, what you want to make sure of is that both of these valves are shut, and they are. And then you want to make sure that your low side connection goes to the low side fitting, and the high side goes to the high side fitting. As long as you get those things right, then you just run these depressors down, and then you should see the pressures reflect on the gauges. This one's a little tight, guys. You also always want to make sure that you're not interfering with the belt line. All right, guys. So as you can see, we can now see that the pressure is about 150 or maybe 140 or so on the gauges. So we've got our gauges hooked up, and let's go ahead and set up our scan tool. All right, guys, so one of the ones I use for Volkswagen is this VCDS Rostec connection here. And so basically all you do is they give you a nice connector to connect to the OBD port, which on the Volkswagens is right there. And so you just go ahead and plug her in, and it'll give you a red light and then a green light if it's plugged in properly. And then whatever device that you're using, I'm going to use this one here to sample the data. You just download their software onto the device, and it does require a regular USB type A, just so as you know. So I'm going to fire this up. All right, so we're going to fire up the Rostec VCDS software here now that the computer is up and ready. All right, so I'm going to show you guys what to do. You go to, if you're using this software, pull it to the center here. You can select a control module. And we'll give it a minute. And then it just so happens that if you want to monitor, you might be able to do it in Auto AC, but I like to do it from the engine control module. That's actually what controls your AC compressor. And then we're going to go to advanced measuring values. That'll make it a little easier. AC compressor. All right, so as you can see, activation is 0%. So I'm going to go over here and I'm going to go ahead and turn the AC on. And as you can see, it should be 19%. So now that we know that, very quickly, let's assume that you just started the car and you're not me and you haven't already figured this out. You want to really quickly go around and see, do you have on your meter, looks like you've got the voltage necessary across the valve to make it work. So remember, we're hooked up to our control valve right down here, and I'm dangerously close to the fans. I'm going to go ahead and get those away. Good. And then we're going to check our AC pressures, and sure enough, with power to the control valve, the refrigerant control valve, we have nothing going on our AC pressures. So not only is the compressor commanding, according to our voltage on the meter here, it's commanding the valve on. Also, according to our ECM, it is also commanding the valve to turn on as well. And if I turn the AC off, it goes to 0. So I just wanted to follow up with you guys here. I just turned the AC off. This is the voltage with the control valve in the off setting. So we're gonna go ahead and cycle it one more time just to be sure that I am accurate. We're gonna cycle it on. There it is, AC on. And go see what the computer is doing. And we are right back at 12.9 volts. So yeah, we've definitely got what appears to be the computer and the circuit intact. operate my AC, and it is not working at all. So looks like we've confirmed the refrigerant control valve is toast. No refrigerant circulating. What you should see, if you're not familiar with AC, is this should start to rise. Depending on the system, it'll be pretty high. It'll be 200 to 300, and then this gauge would go down to somewhere below 35 if it was operating correctly. So, and in the initial stages of failure of this AC control valve, what you would see is you'd see the needle just start to twitch, and so both sides they'll twitch, and then when it finally kicks in, you know, like when the customer says, oh yeah, it doesn't work for a second and then it starts working, then you'll see it start to kind of slowly pull the low side down and the high side go up as the valve starts to work and gets unstuck. So I hope that helps you guys. I'm gonna put this car back together. So I wanted to actually explain why I can know as much as I do with the test I did on the AC control valve, at least with the electrical idea. But before I jump into that, there was a comment that I made while I was underneath the car and tapping into the connector about pulse width modulation and duty cycle. And because this was a concept that, at least from the perspective of interpreting the graph, I was kind of confused on, I thought maybe I'd jump into that and kind of explain just a little bit. And then also explain these things because I 100% believe that if you are working on a circuit like this, if you're not 100% familiar with conceptual electrical, you're probably going to want to use an oscilloscope to diagnose these kinds of failures. And, you know, even if you're not, I just want to kind of run through, like I said, how you can know things with a regular meter, even in the case where the circuit may be a pulse width modulated or duty cycle, because your voltage is probably going to give you a root mean square interpretation of what it thinks the voltage should be based on, you know, the average and the sample rate. So just so you know, this is kind of how things work, and we'll just go ahead and jump in. So as measured from this point right here, which is not across the load, this point right here to ground is what the textbooks were showing. And why was this confusing to me? Well, because with the circuit on, we're at 12.9 volts, like across the valve. And so why in the world would they show me this? Well, because this is not a representation of an on and off signal going through a load. This is actually just a representation of the module side with no load, no use of the electrical energy across the component. So there would be no voltage or potential difference to measure before and after the component. So that being said, when this is turned on and current is flowing through this circuit, it's all used up, hopefully, across the valve. And so when that happens, that leaves zero potential voltage here to actually display on the graph. So that's why you see zero. Measured at this point, it should be 0 volts when the valve is turned on. And then as soon as the valve turns off, it would be as if you're opening this circuit. So no current is flowing, it's an open circuit, and now you can see full potential, voltage potential from the ECM in this circuit, and then it goes up to 12, or ECM available voltage or charging system voltage, whatever the ECM is using to supply this. Sometimes it could be 5 volts. So depending on the circuit, you might see a different high and low. But anyway, so the difference between pulse width modulated and duty cycle, you'll notice pulse width modulated has a different on-off duration each time it may activate the component. So it has full freedom. The ECM has full freedom, or the control module, whatever is using it, has full freedom to vary on and off time. Whereas duty cycle is the same, it's equal on, off, every single time. or uniform, I should say. It's uniform. So this would be 50-50. So you've got 50% off, 50% on. And then to further illustrate, 10% would look like 90% off, 10% on, but it is always the same exact length of time for off and on. That being said, why do I know as much as I know from the tests I did? This is what I got as a result, and this is how I was measuring it according to the diagram. Well, because I have such a high available voltage to use at the valve with the current flowing through the circuit, and we know that that was the case because it did turn on, ECM was definitely commanding it on because there's no other way for the voltage to be available to this valve without the ECM turning it on. So I know the ECM is good because of this number. Now, do I know that the circuit is 100% intact because of this number? If I'm being 100% honest, no, but I have a very good reason to believe that it is. Because if, let's say, I had a connection issue anywhere from the module itself to the connectors to the wires to the valve on either leg, I would not see nearly as much available voltage to the valve with the AC system turned on. And so then that would prompt me to look for one of these following scenarios. The scenario in which there's an open circuit near the ECM connector. And so in this case, what we would see, because essentially the way static charges work, if you're connected to the battery ground through a conductor, which would be the ECM through the body ground of the car, all the way to the negative side of the battery, and then all the way through the component, you're going to have a static negative charge if current's not flowing. And then because your voltmeter measures potential difference, it's going to say 0. So you're measuring no difference between ground or positive side of this control valve. So now you know, hey, I have an open circuit somewhere. I don't have the voltage that I need or the electric energy that I would need to run this valve. And so what you can do is you can then do this following test. You could say, okay, you could do this either or. The second scenario is just below here. And let's say you take the ground leg and you check against battery ground, but you leave the positive that you know is positive from the wiring diagram. Like I said, never guess at this stuff. Always look at the wiring diagram. But let's say that you have a positive side and check to ground with your meter that says 0 volts. Well, now you know that, hey, it's as if I touch both of these to the negative terminal of the battery because I'm on the positive side and I have no positive voltage. And so now you kind of know that, hey, like my ground side is connected to a conductor, most likely, because I have 0 volts. And if you know all of the design of the circuit, you can make an inference from here without doing an additional test and say my open must be on the positive side of the circuit. But if you're not sure how the circuit works and you want to be absolutely sure, what you would do is you would just switch the test leads around. And you would say, okay, I'm going to measure the negative side of the connector at the control valve against the positive terminal of the battery. And then you should see system voltage. So once you see that, you know, oh, okay, now I know that the open is on the power side instead of guessing. So what's the opposite scenario? It's exactly, hey, instead of it looking like we're connected to the negative post to the battery, we're connected to the positive post through the control module, through the valve, and all the way up. And so once again, no potential difference across. You see 0. You don't know which side it's on until you do an additional test. And so let's say you check the ground side against the positive and you say, oh, well, I see 0 volts. Well, then there's no difference between the ground side and the positive side. Like I said, if you know the design of the circuit, then you can make an inference from here and say, well, most definitely I know that I'm not getting voltage to the valve because it's on the ground side, because, just the alternative case. But if, once again, you're not sure, you just do the exact opposite. You say, okay, well, I'm tapped into the power side of the valve, and I'm going to check that against the ground side of the battery. And then you see potential voltage here, which would tell you, oh, I'm connected all the way to the battery, and we're there. We've got the potential energy to operate this valve if I was connected to ground on the ground side. And so now I can conclude that my open is definitely on the ground side, and there you go. But since I didn't see any of these scenarios, I didn't see 0 volts. And arguably, you never see 0 volts because the engine control module is probably always going to have some available voltage. Arguably, in this scenario here, you're going to see a different voltage than this scenario here, because if you're grounding through the body ground and engine control module, yeah, you might see charging system voltage because you're measuring it at the battery, vehicle battery. On this side, you would probably see whatever the engine control module has available, which would be indicated on the scan tool. And so if that matched what you saw on your meter to your ground check, then you could say, okay, it looks like we have a ground leg problem in this compressor control valve circuit, and you want to verify that before you go replacing the control valve. So hopefully that makes sense. Hopefully that explains why I know that the control valve is likely failed, because I have all of my available voltage that I would expect to see, void of any potential errors, and I don't necessarily need to see on the oscilloscope any additional information because I have such a high available voltage to the valve. There's no restriction or inhibition of the valve operation. Hopefully this helps you guys. Thanks for watching. Okay, I wanted to jump back on one real quick moment. It turns out you can actually see a little bit more information. I think the factory scan tool would probably illuminate this message a little bit more, but there's a malfunction in the system. If I turn it on though, you can see that it has a compressor speed that it will display, a compressor load in Newton meters, and then you have, you can display outside temperature, refrigerant pressure, things like that. So anyway, I hope this was informative for y'all. I hope that this helps if you are working on a Volkswagen AC. If you have questions, leave them in the comments. I'd be happy to try to answer them for you. Absolutely love electrical work, AC work. I love finding out these hard problems. So anyway, tell me about your experience on any of these types of AC systems. I believe Kia and Hyundai also use these, so they would also be an example of a system with a variable displacement compressor and a similarly designed AC refrigerant control valve, where the compressor is kind of always engaged, but not always pumping refrigerant. So anyway, y'all have a great day. Thanks for watching. I'll see y'all in the next one.